Right then, moments. What is a moment? Define a moment. Well, I've written it out here. A moment is a force multiplied by the perpendicular distance to the line of action of the force. Commit that to memory, regurgitate it in the exam if you're asked to say what a moment is. You could also say that a moment is a turning effect, but that's a bit naff. Just remember that word for word and regurgitate it. Okay. You have to compare the sizes and directions of the force from the chain. Sorry, the moments. I do apologise. I was planning on stressing that you shouldn't confuse the force and the moment as well, so naughty me. You have to compare the sizes and directions of the moments of the chain and the foot. Okay, so read the question. It says compare the sizes and directions of the moments. So not the forces, the moments. So the moment provided by the chain is, there's the pivot, so that force is trying to rotate it in that direction. So from the chain, it's going in that trying to rotate it in that direction. From the foot, there's the pivot, there's the force, it's trying to rotate it in the opposite direction, like that. So the directions are opposite. That's the first thing. Okay. The pedal is stationary. It's got two moments acting on it and the pedal is stationary. That must mean that the sizes of the moments are the same. Okay? So the magnitude, if you like, let's use a physics word, or the size of these two moments, because it's stationary, it must be the same. So to summarize, the moments, not the forces, the moments, same size, opposite directions. Okay, good. Right, next bit. We have to work out the force due to the chain, and we're told we have the following information. The force from the foot, FF, is 1.5 newtons. Okay. The distance from the pivot, the perpendicular distance from the pivot to FF is 12 centimeters. Okay. And the perpendicular distance from the chain to the pivot, so that distance there, is 20 centimeters. Okay, so what equation are we going to use? Well, again, if there's two moments acting on something and it's stationary, the two moments are equal. The moment is force times perpendicular distance, so therefore FC times that distance equals FF times that distance. So FC, force due to the chain, times perpendicular distance due to the chain, equals force due to the foot times perpendicular distance due to the foot. Okay, it's the moments equation. And we want FC, so make FC the subject. Let's bring the DC down there and stick in the numbers. Force due to the foot is 1.5 newtons times distance due to the foot is 12 centimetres. Now, we don't have to convert into metres in this case because you've got one distance on the top and one on the bottom. So it's like a ratio. Whatever the units are, they're going to cancel. So we can leave it in centimetres. So divided by distance due to the chain is 20. Okay, stick that in your calculator or do it in your head if you want, and it comes out to be 0.9 newtons. There we go, 0.9 newtons. Super. Right, next. Okay, yeah. They've given you this graph and you've got something like that, okay, for 9 newtons, 6 newtons and 3 newtons, and this is a length of lever and this is the speed of the beta. That thing, the hammer thing being the beta. Okay, and you have to, it's only 2 marks this question. You have to say, how does the length of the lever affect the loudness? And they tell you that the faster it moves, the louder it is. So we can think of that as loudness. Okay? Right, so for the first mark, you have to talk about the 3 Newton case. So you're applying a force of 3 newtons with your foot, and for different levers you get this profile. Well, it's only 1 mark, so you just have to say that the longer the lever, the less quiet the noise, or the shorter the lever, the louder the noise. Okay, that's it. But now here's the tricky bit. They ask you to do the same thing for a range of 3 newtons to 9 newtons. Now, in an exam, you know, you're under pressure. It might not be obvious what they're really asking for here. So you've got to think about this, unfortunately. And what can you extract? You've got to ask yourself, what can you extract from this diagram? What do you notice about it? What are they getting at? I don't think it's a brilliant question. It's a stupid question, okay? But the thing that you're expected to notice is that for longer levers, okay, if you apply a range of forces, you get a larger range of loudness, right? Than if you have a shorter lever, if you apply the same range of forces with your foot, you get a smaller range of loudness. That's what they're looking for. So it's just an example of an exam question where it might not be obvious what they're trying to get at. And there's nothing wrong in that case with writing anything you can think of down. It doesn't matter that you get a load of stuff down that might be even wrong or just correct but not what they're looking for. As long as somewhere on the page there's what they're looking for, you'll get the marks. So don't worry about writing too much with stupid questions like this. All right, that's it. Yeah, so to say with longer levers, you get a greater range of loudness.